Hey math kids, today we're going to talk about some coordinate geometry, and let's just start right off with the problem. So, whoa, that was not very good. So I'm trying to draw a parallelogram. Okay, so it's given that this is a parallelogram, and we know this point is 4, 6. We know this point is 8, 10. And then the diagonals are drawn, and where they cross is point E. I guess we'll just name all these A, B, C, D. Okay, so that's the info we need, that we know, and we want to know the coordinates of E. So E is x, y, and we want to know what those values are. Now, a property of parallelograms, if you remember from that section, is that they cross each other and bisect. So that means that is congruent to that, and those are also congruent to each other. They're not all necessarily the same length. Only the double marks are congruent to each other, and the single marks are congruent to each other. So, knowing that, we know that E is the midpoint of CB. So E is midpoint of CB. And so knowing that, we can use the midpoint formula, which is x2 plus x1 over 2, and y2 plus y1 over 2. So the midpoint formula, or you can just take the average of the x's and average of the y's. It's that simple. So we get 8 plus 4 over 2. We get 10 plus 6 over 2. So that's 12 over 2. 16 over 2. So that becomes 6. That becomes 8. And those are the coordinates of E. Okay? Move on from that. This one's a little more involved, and so we're given some coordinates. Wx, y, z. Okay, so we're given a quadrilateral with those coordinates. So those are all in the first quadrant. So we have one at 1, 4, that's W. Then we have one at 5, 1. And then 8, 4. So that was X, that's Y, and then 5, 7, 1, 2, 3, 4, 5. 5, 6, 7. Okay. So we have a quadrilateral that's defined by those coordinates. Okay, so we want to know what type. So to figure out what type of quadrilateral this is, I would start with sides. So really our choices are parallelogram, so we'd have to prove that the sides are parallel, rhombus, rectangle, square, maybe a kite, or possibly just a quadrilateral, like none of the above. So we want to say as much detail as we can about this. So I would just start with some side length stuff. So if we, or even, we can start so many places. So we can start with, let's first prove that it's a parallelogram, because if it's not a parallelogram, it's not any of the other ones. So for it to be parallel, we need to look at the slope of opposite sides. And so if we go from 1, let's see, if we're doing x to y, we're going to go from 1 to 4, so the rise is 3, and the run is going to be 3 as well, and so this has a slope of 1. Let's clean that up a little bit. So we got 1, 2, 3, 1, 2, 3, okay. So this needs to have a slope of 1, or it's not even a parallelogram. So we go 1, 2, 3 up, 1, 2, 3, 4. So it's 3 over 4. Since these are not parallel, can't be a parallelogram, can't be a rhombus, can't be a rectangle, can't be a square. Now, could be a kite. So a kite, just in case you don't know, is where these two are congruent, these two are congruent, okay? But these side, it's not a parallelogram necessarily. So now we need to do lengths. So we need to test x and y, or sorry, xy and yz to see if they're the same length. So x to y, if we do a distance formula, we're going to take our x values, let's see, just to review, it's going to be x2 minus x1 squared plus y2 minus y1 squared, and then we square root that. Okay. Now another way we could think of it, with the distance formula, that would work, right? But if we're doing this, it's just 1, 2, 3, and then 1, 2, 3, and then this hypotenuse. So if we think of that as a right triangle, we get 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. Square root both sides. C equals the square root of 18. Okay? So the length of this is square root of 18. Now if we look at this one, we went 1, 2, 3. And we go 1, 2, 3. Since that's the same, 3 and 3, it's going to work out the same. So this is also the square root of 18. So far, it looks like it could be a kite. Now, if we do the same thing here, we go 1, 2, 3, 4, and then 1, 2, 3. Right here is going to be 4 and 1, 2, 3. And so we don't actually need to find the value of the hypotenuse, because we know they're both going to be 4 squared plus 3 squared equals c squared. So if we solve for c, it's going to be the same. And so this one ended up being a kite. So it's kind of like this. So on the diagram, this is congruent to this, and then this is congruent to this. Okay? Moving on. Let's see if I can fit one in there. Okay, this one isn't too hard, but it's confusing how it's worded. So it says, write an equation that represents the set of all points, the square root of 5 units away from -2, 5. So all that means is that this is the radius, and this is the center of a circle. And so if we write using this formula, our circle formula, what we're going to get, this is our h value, but we switch it, so +2. This is our y value, but we switch it, so it's -5. And then we square our radius, and so it's just going to be a 5, because if we square a square root, it cancels. Okay? I think that's about it that we need to talk about. Nah, let's see a few more.